In the early 1950s, Alco was still trying to claw its way back into the diesel race. They believed a comeback was possible. What they didn't know was that their most trusted partner was quietly preparing a move that would wipe them off the map. The betrayal didn't happen on a factory floor or in a boardroom. It happened in plain sight, and Alco never saw it coming. At the start of the 20th century, Alco wasn't just another locomotive builder. It was the backbone of American railroading. When 8 major steam shops merged in 1901, they created a company with the talent, foundry capacity, and engineering depth to dominate every major railroad in the country. Schenectady Works became a small city built around one purpose: producing the most powerful machines on rails. For decades, Alco delivered exactly that. Their Hudsons carried heavyweight passenger trains at speeds that seemed impossible for the era. Their Challengers and Big Boys hauled freight over mountain grades that had defeated smaller engines for years. When foreign railways wanted American power, they went to Alco. Orders flowed in from South America, Asia, and Canada, reinforcing the idea that no one could match their combination of muscle and reliability. This success created confidence across the entire organization. Alco had solved every problem the steam era threw at them. They pushed superheating further than their competitors, mastered complex valve gear, and produced articulated locomotives that handled curves while pulling thousands of tons. With that track record, it was easy for the company to assume their engineering instincts were still correct as the industry changed. But steam excellence came with a price. Alco remained committed to perfecting a technology that was reaching its limits. Even as experimental diesel units appeared in yards during the 1930s, Alco stayed focused on bigger boilers, higher pressures, and more efficient steam cycles. To their engineers, diesel still looked unproven, and they believed railroads would return to steam once the early excitement faded. World War II reinforced this belief. Alco was kept busy producing steam locomotives and military equipment under government contracts, while EMD continued expanding its diesel expertise through marine and auxiliary power projects that gave it invaluable real-world experience. By the time the war ended, EMD had mature diesel engines in full production. Alco had expertise in a technology that was already losing ground. They still had the factories, the workforce, and the reputation, but they no longer had the momentum the industry demanded. For the first time, Alco wasn't leading the market. They were trying to catch it. This was the moment the company believed it could recover. They had the brand, the history, and an enormous manufacturing base. What they didn't realize was that their biggest threat wouldn't come from a rival across town. It would come from the partner they trusted more than anyone else. When the diesel era finally hit full force, Alco did what it had always done. It tried to engineer its way out of trouble. The company knew EMD had a head start, but they believed they could catch up with one decisive move, one modern engine that would restore their place at the top of the market. That engine was the 244, and on paper it looked like the answer. The 244 was designed as a 4-stroke V-type engine meant to go toe-to-toe with EMD's 2-stroke 567 in freight and passenger service. It promised good fuel economy, competitive power, and a compact package that fit neatly under a road locomotive hood. From Alco's point of view, it was the clean break they needed from the steam era. If they could prove the 244 in the field, they could still convince railroads that Alco knew how to build the future, not just the past. Reality did not cooperate. The 244 went into service before it was truly ready, and railroad shops discovered that the engine's weak points were not small annoyances. They were showstoppers. Turbochargers overheated and failed. High-pressure fuel pumps leaked diesel into the crankcase. Oil became thin and contaminated. Bearings started to wipe, and crankshafts failed under loads the engine should have handled easily. Internally routed oil and coolant passages, which had looked efficient on the drafting table, became a maintenance nightmare. A small internal leak could turn into a major failure that required extensive teardown, vibration, and thermal cycling did the rest. Cracks spread through blocks and heads, seals failed, and engines that were supposed to run long miles between major work spent more time in pieces on shop floors. The railroads did not shrug this off. The Nickel Plate Road ordered a substantial fleet of FA units powered by the 244, and quickly learned how fragile the design really was. Within a couple of years, a large portion of the fleet was sidelined with major failures. Shop crews wrote blunt reports that did not read like technical debates. They read like indictments. They called the 244 fundamentally unfit for road service and warned management that these units would drain money for as long as they stayed on the roster. Other railroads saw similar patterns. The New York Central's 244 powered units developed reputations as hangar queens, locomotives that seemed to spend more days in the back of the shop than out on the main line earning revenue. Mechanical departments that had once trusted Alco steam power now started telling their purchasing people something Alco could not afford to hear, that the company's diesels could not be trusted. While all this was happening, EMD's 567 was building the reputation Alco had hoped to claim. Railroads could lash up multiple units, run them hard across mountain grades, and then send them back out after basic servicing. Parts were standardized, procedures were straightforward, and reliability was boring in the best possible way. Every 244 failure made the 567 look better. The damage to Alco was not just mechanical, it was financial and psychological. Every locomotive that sat in a shop bay represented lost tonnage, missed schedules, crew overtime, and frustrated customers. Those losses showed up on railroad balance sheets, and the people who read those sheets started to rethink who they wanted as a long-term supplier. This is where GE's role became critical. Alco did not build a complete diesel locomotive alone. Since the early days of diesel-electric, they had relied on General Electric for generators, traction motors, and control systems. GE supplied the electrical half of the equation, the systems that turned the engine's power into tractive effort on the rails. That partnership helped create landmark designs like the RS-1, and for years it seemed like a perfect arrangement. By the early 1950s, that arrangement looked more like dependence. With the 244 under fire, Alco desperately needed the electrical side of its locomotives to be bulletproof. Instead, railroad shops began seeing a pattern that made things worse. Electrical failures on Alco units became a constant headache. Traction motors overheated or grounded out main generators failed more often than they should have. Control systems glitched and shut units down out on the road. EMD units, which used their own electrical gear, did not have those problems at the same scale. Shop foremen noticed that EMD locomotives could run for long stretches without major electrical issues. Alco units, which depended on GE's components, seemed cursed with a combination of mechanical and electrical vulnerability. From Alco's side of the fence, the logic was simple. They could not design and build their own electrical systems from scratch without years of investment they did not have. They had to keep relying on GE. Without GE, there would be no complete locomotive to sell at all. So they kept sending orders for traction motors and generators to the same partner their customers were quietly losing confidence in. Meanwhile, GE was gaining something far more valuable than purchase orders. They were gaining experience. Every locomotive they equipped with traction motors and generators taught them something about load cycles, failure modes, and how railroads actually use their power. They learned which designs held up to abuse, which configurations railroads liked, and what shop crews hated. Alco assumed GE was learning how to serve them better. In reality, GE was learning how to build without them. By the time the 244's reputation was beyond repair, Alco's position in the market was weaker than it had ever been. They were seen as a company that built unreliable engines and sold locomotives that spent too much time in the shop. EMD was the safe choice. GE held the keys to the electrical side of the business. Alco stood in the middle, trying to prove they still mattered while their most important partner was quietly preparing to step around them. Alco thought the crisis was a matter of fixing an engine and proving they could build a better one next time. They were focused on the crankshaft, the block, the turbo, the fuel system. They didn't realize that the real risk was not inside the engine compartment at all. It was in the relationship that powered the rest of the locomotive, the one they had trusted for decades and could no longer live without. By the early 1950s, Alco believed the worst of the diesel transition was behind them. The 244 had damaged their reputation, but they assumed they could recover by improving the design and proving themselves with better locomotives. What they didn't see was that their greatest vulnerability wasn't the engine at all. It was the partnership that powered the rest of the locomotive. While Alco was focused on pistons, bearings, and turbochargers, GE was watching the entire industry shift toward diesel-electric power and realizing it no longer needed Alco to be in that picture. For decades, GE supplied Alco with the electrical half of every locomotive: traction motors, generators, control equipment. That relationship began when diesel was still experimental. Back then, GE had no interest in full locomotive production. They were content supplying components while Alco handled assembly, engineering, and customer relationships. The roles were clear. GE made the electrical systems, Alco made the locomotives. That arrangement helped both sides through the early years of diesel-electric development. But by 1950, GE looked nothing like the modest partner Alco had grown comfortable with. They had spent the war building electrical equipment for the most demanding machines on Earth: naval vessels, industrial plants, and military hardware. Their engineering divisions grew, their research programs expanded, and their confidence increased as they watched the diesel-electric concept go from niche to standard. Inside GE, engineers began realizing something Alco never considered. The company already had the knowledge, capacity, and financial depth to build locomotives themselves. The turning point came when GE engineers began studying failures reported on Alco units. Every traction motor that overheated, every generator that failed under load, every control system that shut down a locomotive in the field taught GE something about how diesels behaved in real service. They learned exactly what railroads wanted, what they hated, and what they refused to tolerate. GE didn't have to guess. Alco's locomotives did the testing for them. This wasn't espionage, it was access. GE had a front-row seat to the entire diesel-electric transition through its own components, and by the early 1950s, GE had learned more about the demands of railroad service than almost any prime mover manufacturer in the country. Meanwhile, at Alco, the picture was much different. They were scrambling to fix the 244, trying to convince railroads that they could still compete, and relying more heavily than ever on GE to supply the electrical side of their locomotives. Every order Alco placed with GE widened the gap in knowledge and experience. GE's engineers understood the realities of the diesel-electric market better than the manufacturer that actually built the locomotives. By 1953, GE determined that the partnership had run its course. They ended joint marketing and development agreements, but continued to supply electrical components for Alco locomotives on a contract basis. Alco treated it as an unwelcome shift, but not a fatal one. They assumed GE was simply reallocating resources or reorganizing operations. No one inside Alco understood just how significant that shift really was. The truth became clearer in the years that followed. GE didn't just end the partnership, they had outgrown it. Without telling Alco, GE had already begun laying the groundwork for a full-scale locomotive program. They recruited engineers, expanded manufacturing lines, and built new testing capabilities. While Alco struggled to keep fleets running, GE refined designs for traction motors and electrical systems that were more powerful, more reliable, and easier to maintain than anything the partnership had ever produced together. Alco didn't realize it, but GE was preparing to become their biggest competitor. The signs of this shift appeared gradually. Railroads began reporting that GE's support on Alco electrical gear was slower than before. Replacement parts took longer to arrive. Technical questions weren't answered as quickly. Service bulletins came out with less frequency. These changes were subtle enough that Alco could rationalize them, but railroad mechanical departments noticed the pattern clearly. Something about GE's priorities had changed. At the same time, EMD units built entirely with in-house systems were running thousands of miles without major electrical failures. Shop crews could keep fleets moving with predictable maintenance routines. When a railroad compared an EMD locomotive to an Alco unit equipped with GE electrical gear, the difference was obvious. The Alco might run well for a while, but electrical gremlins appeared unpredictably and often at inconvenient times. Railroads began to question why GE couldn't deliver the same level of reliability for Alco that EMD delivered for itself. The answer was simple. GE was no longer working for Alco's long-term success. By the late 1950s, GE made its ambitions clear, and in 1959 it unveiled the Universal Series, a new generation of road locomotives aimed directly at Alco and EMD's market share. Leading this effort was the U-25B, GE's first full-size domestic road switcher. The U-25B stood out with industry-leading horsepower, advanced traction motors, and sophisticated controls, showcasing everything GE had learned from years of supplying equipment to other builders. It wasn't subtle. The U-25B was the locomotive GE had been preparing since the moment the partnership ended. When railroads began comparing it to Alco's offerings, the difference was stark. GE's electrical systems were stronger. Their support was better organized. Their financing options were more attractive, backed by one of the world's largest corporations. And unlike Alco, GE didn't carry the baggage of the 244. They were new, confident, capable, and backed by the full weight of a corporate empire. Alco never had a chance to catch up. The betrayal was not a dramatic announcement. It wasn't a confrontation, and it didn't unfold in a single moment. It happened in the quiet spaces between service calls, in the delays that frustrated shop crews, and the new priorities emerging inside GE's engineering divisions. Alco believed they still had an ally. In reality, they had spent years feeding information, experience, and market insight to the company that was about to replace them. By the time Alco realized what GE had done, the damage was irreversible. GE had used the partnership to understand the locomotive business from the inside, then stepped into the market fully equipped with knowledge, technology, and timing that left Alco with no realistic path to recover. Alco tried to recover with the 251, a far better engine than the 244 in every way that mattered. It ran cooler, handled load changes more smoothly, and held up under stress without the constant breakdowns that had ruined Alco's reputation. On paper, it was the engine that could have changed everything. But railroads weren't interested in technical improvements anymore. They cared about risk. And Alco represented the one thing railroads hated most: uncertainty. While Alco fought to convince buyers they had turned a corner, GE moved forward without hesitation. The Universal Series grew, the U-25B found customers quickly, and GE's financial muscle made their locomotives easier for railroads to justify, even when prices were higher. EMD held its massive lead, but GE was the company gaining momentum with every new order. Alco was no longer competing for market share, they were competing for survival. By the mid-1960s, the numbers told the whole story. EMD dominated the industry, GE was rising fast, and Alco had slipped into single-digit territory. Their locomotives weren't bad, they just weren't trusted, and trust was the one advantage Alco couldn't rebuild. Not with their history, not with their reputation, not with GE and EMD filling every gap Alco once occupied. In 1969, the company stopped trying. Locomotive production at Schenectady ended, the lights went out in the foundries, and the plant that had once built the greatest steam locomotives in America closed its doors. GE had taken its place in the market, and there was nothing left for Alco to reclaim.